So whatever you do over here is just simply doing a backtracking, and it's under the category of like doing a subset. So what you do is like you find every single combination, and you are not doing a permutation where you don't care about whether like there's some form of um, you know um, every single combination. So say for example 1 2 3, right? You like 3 to 1 is something that you don't really want to actually create, because that falls under like permutation. So in a way you can call it like distinct. So I mean, like one of like the properties I believe is therefore like distinct value in like the whole list. So what you overdo over here you do is that maybe say that you got these 3 unique values, 1 2 and 3, right? So the first combi, we start off with like the first value. So it's either you have a value or you don't have like a value. So therefore you get a 1 and an empty slot. And now you move on to actually talk about like the 2. Let's talk about the story of like the 2. It's either you have the 2 or you have like an empty item. So similarly within like this chance, the next chance you also do the same thing. It's either have a 2 or empty. And if you were to expand throughout the entire thing, it's either you get a 2 or you get a empty. It's either you get a 2 or you get the empty. And now obviously you solve like you included into the algorithm 1 and 2, you left with a 3. So it's either you get a 3 or you get the empty. And you notice like the window is getting bigger and bigger because the deeper you go in, there's more items. So notice I'm already having a hard time to actually write already. So now like it echoes throughout, like is it a 3 or like empty? So look over here, is there a 3 or is there an empty? Is there a 3 or is there an empty? Is there a 3 or empty? Is there a 3 or Mr. Empty? And notice if you were to calculate the combination after you do all the calculation, is that the first combi is obviously 2. It's either one or the other. So it's like having like the choice is either 1 or an empty. So obviously you have like a combination of like 2 choices. But as you expand like another choice, so you sort of like multiply by another like a choice of like 2 choices, a 2 or an empty, an item with another, you multiply by this, you get the value of like 4. And you have another one, is either a 3 or an empty. You multiply by another choices of like 2 choices amongst these 4 items. So you multiply by another 2, you derive with getting an 8. So this is like 2 possibilities, 4 possibilities, and a total of like 8 possibilities. And in fact, because each time is like 2 choices, 2 choices, and 2 choices, and whenever everything is always having like the same number of choices, it's towards like the power of n. And 2 choices, you like how many times are you doing this? You're doing 1 time, 2 time, 3 time. So in fact 2 power of 3, and where n is also like your sort of like your number of like in array items. So this is like your in array items, like the number of it. And if you were to actually see in this way, but like supposedly whatever this this whole entirety thing is they are actually gonna like do is actually they are fundamentally they are casting the spell of backtracking. In fact, this is the character backtracking. And I feel like whatever we've been talking about, like the spell, is a lot to do with the 2 power of n. Right? It's running through distinct combination. And when it's that, it's definitely to do with like backtracking character. I think whatever the Leetcode is actually trying to ask, like in the rulebook, it first and foremost it says that it wants like some form of like distinct value. So if it's like distinct value, it just means that it's talking to like 2 power of n items. It's not like crazy expensive because it's like distinct. Distinct is just like a form of like limitation. You are very happy, you're very much willing to actually do the item, and it will fall under the 2 power of n category. And I mean by means that like the core objective of this whole item, it's really comes down to actually being able to actually create a unique list, which in fact right over here 1 3 1 2, if you were to notice, each of the sets it's unique by of its own. And I just feel like whatever we're doing here, we are constantly asking ourselves like, okay, the 2 choices that we can actually make. When you talk about like 2 choices, it kind of like links to like the root spell of split. And when it's talking about like this split spell, it's talking about trees. And when you talk about trees, it's very much linked to backtracking. Backtracking and trees, they are very much correlated in that sense. And this one, it's casting a lot of the split. The moment it casts a lot of split, it's tree. If it's tree, if it's also like backtracking, and because like you're finding combinations, all the more it falls under the category of like backtracking. This is also another hint. And I mean like fundamentally there's not much that it covers. What's really like difficult, I feel like it's just basically like inputting your code into the backtracking, which is basically all the fundamentals of like coding, what it involves. And what we have to actually discuss is that how about having like the brute force to actually fight against the main character backtracking. So I mean, in fact, they term this whole backtracking thing to be a very brute force item, where constantly create as all this every single combination, what not have you. So in fact, for the first time that I actually say that this brute force is whatever this character is actually wanting to do in the very first place. So yep, with that everything comes to an end.